Dear learners, welcome in this video session. Today I am going to discuss about two-way ANOVA test. As in my previous lecture, I have discussed for one-way ANOVA test. So now we will see two-way ANOVA test. So two-way ANOVA test. So first of all, when we can apply two-way ANOVA test, or we can say why there is a need of two-way ANOVA test. This is the question. So it is used when the data are classified on the basis of two factors. That's why here we can apply the two-way ANOVA test. For example, the agricultural output. If we are talking about the agricultural output, it's a one business we can say. So it may be classified on the basis of two factors. One is different varieties of seeds and on the basis of different varieties of fertilizers used. So here we can apply the two-way ANOVA because here one thing is depend on two factor. As like the saying, a business firm may have its sales data classified on the basis of different salesmen and also on the basis of sales in a different regions. So here also two factors are there that is depend on a one thing, or we can say one thing is depend on two factors. That's why here we can include the two-way ANOVA test. Such a two-way design may have a repeated measurements of each factor or may not have repeated values. For example, ANOVA technique in context of two-way design when repeated values are not there. What we have to do means, as we do not have a repeated values, we cannot directly compute the sum of square within the sample as we had done in the one-way ANOVA test. So here what we have to do? We have to calculate this residual, or we can say error variation by subtraction. Once when we have to do this, once we have calculated the sum of squares for total variance and for variance between the varieties of one treatment as also for a variance between varieties of the other treatment. After that we can calculate the residual, or we can say the error variation by subtraction. Now we will see these steps for two-way ANOVA. So what are these steps for two-way ANOVA? So first step, what we have to do, here we can use the coding device to simplify the system, or we can say to simplify the task. We can use the coding device. After that, after deciding the code, take the total of the values of individual items and we can say their coded values. We can take the coded values also in all the samples and call it capital T. It's a coded value. What is T? It's a total of values of individual items. This is the second step. We have to work out the correction factor. By this equation, it's a T square divided by N. N is the number of sample and T means a total of the values of individual items. Now after that what we have to do? So the next step is find out the square of all the item values, or we can say the coded values. One by one we have to find the square of item values and then take its total. Subtract the correction factor from this total to obtain the sum of square of deviation for total variance. Symbolically we can write it as like this. Means we can say the sum of squares of deviation for total variance, or we can say total SS. It's a total sum of square of deviation is equal to this equation. We can put this equation to find this total SS. After that, what we have to do? Once we have find out this total SS, what we have to do? We have to find the SS for columns as well as rows. So after that what we have to do? So take the total of different columns and then obtain the square of each column total. After that, we have to divide such squared values of each column by the number of items in the concerning column and take the total of a result thus obtained. So finally what we have to do? Subtract the correction factor from this total to obtain the sum of square of deviation for variance between column, or we can say as S between column. We have to subtract the correction factor from this SS between column. Now the same procedure we have to apply for rows to find out the SS between rows. So after that what we have to do? After that we have to take the total of a different rows and then obtain the square of each row total, and we have to divide again the same like column. We have to divide such square values of each row by the number of items in the corresponding row and take the total of the result thus obtained. So finally whatever result we are getting, we have to subtract the correction factor from the total of this sum of square, means we can say SS between the rows. Now after that what is the next step? So sum of squares of deviation for residual, or we can say error variance, can be worked out by subtracting the result of sum of fifth and sixth step. Means what? Fifth and sixth means this two step, SS between columns and SS between rows. So we have to do sum of the SS between column and SS between rows from the result of the fourth step stated above, means this one, total SS. So we have to minus the sum of SS between column and SS between rows from the total SS. So whatever answer we will get is known as SS for residual, or we can say error variance. Now the degree of freedom. So how we can find, or what is the degree of freedom for a different factors? So degree of freedom can be worked out as under, we can see over here different degree of freedoms are there. So degree of freedom for total variance is equal to C into R. See what is C over here? It's a number of column. What is R? It's a number of rows. So what is degree of freedom for total variance? Is equal to C into R, means number of column into number of rows minus 1. Now what is degree of freedom for variance between column? So it's a number of column minus 1, as like the same, whatever the variance between rows, it's a R minus 1, means number of rows minus 1. And what is the degree of freedom for residual variance? Is a C minus 1 into R minus 1, means number of columns minus 1 into number of rows minus 1. So these are the formulas how we can find the degree of freedom. Now this is the summary. Here there is a source of variation. It's a sum of square, degree of freedom, mean square and F ratio. Finally we have to find out the F ratio. So it is given over here. So between columns treatment, the equation we can apply is this. Between column treatment, degree of freedom will be C minus 1. Then mean square. See here, the S is between column divided by C minus 1. And thus whatever MS we are getting, it's a mean square for between column divided by mean square residual. Now what is it? So whatever mean square we are getting is a residual variance that provides the basis for F ratio. It is a variance between the column treatment and between the rows treatment. We can say that. So what is MS residual? It should be always due to the functions of the sampling. So it provides the basis for significance test. Now both the F ratios compare with their corresponding table values for given degree of freedom at a specified level of significance. So F ratio is a variation between the columns and it should be equal to, or we can say greater than, its table value. Then the difference among the column means. And when it's happened, it's known as the significant, or we can say it considered as a significant. So similarly, F ratio concerning, when we are concerning about rows, it will be same. It will be very clear by the examples. So in the next lecture, we will see the examples for one-way ANOVA and two-way ANOVA test. Now this is the second, it's a between rows treatment and residual or error. Now this is the total. So this is how the degree of freedom is applied when there is a sum of squares. And what will be the mean square? How we can find the F ratio for that? So in the next lecture, we will see the calculations. Thank you, dear learners. Keep learning.